Okay, let's dive right into this explainer and tackle a massive frustration I know a lot of us have felt. You know the drill. You spend months learning a completely hot programming language, only to watch the hype fizzle out a mere 6 months later. Look, if you are tired of jumping from syntax to syntax and feeling like you're just constantly starting over, you're exactly in the right place.
Today, we're totally reframing how you learn to code. We're going to walk through a 6-step evolutionary journey. We'll hit the coding hype trap, think before you code, the algorithm blueprint, laying the foundation, the 2026 tool belt, and wrap it all up with mixing languages smartly. Let's get into it. Section 1, the coding hype trap. Let's just start with the elephant in the room that traps so many aspiring engineers year after year. Literally, everyone asks this question. But here's the thing. Jumping from language to language based purely on GitHub stars or Stack Overflow popularity, it's a guaranteed recipe for burnout. It completely ignores the actual learning curve, not to mention the day-to-day headaches you're going to face when you sit down to build something real.
Traditional courses always seem to start by overwhelming you with syntax, right? They just throw curly braces and semicolons at you before you even know what it is you're trying to build. We absolutely need to flip that script. The goal here isn't to memorize rules. It's about computational problem solving and finding real utility.
Section 2. Think before you code. So before you even think about touching a keyboard, you have to build your absolute bedrock, computational thinking.
We have this rule of 4 that outlines how to actually interpret a problem and generate a solution a computer can execute. You break things down, you spot the patterns, you filter out all the noise, and then you draw up the steps. Let's quickly zoom in on 2 of the most vital pillars here.
First up is decomposition. Say you need to add the numbers 1 through 200. Doing that individually would take forever, right? But decomposition lets us look at it differently. Pair 1 with 200, you get 201. Pair 2 with 199, you get 201. Suddenly you realize you just have 100 pairs that all equal 201. Boom! You've taken this massive problem, broken it down into a highly manageable subproblem, and solved it instantly.
Then we have abstraction. This is all about brutally ignoring useless information. If you're building a digital model of a house for a software program, abstraction means you don't care about the paint color. You ignore the balcony size. You don't care what brand the front door is. You reduce that house strictly down to its core function, shelter. You just strip away everything the computer doesn't actually need to know.
Section 3, the algorithm blueprint. Now we take those foundational pillars and draw up our architectural blueprints.
You might be super tempted to just pop open your IDE and start typing. We've all been there. But honestly, skipping the blueprint phase and rushing straight to code is exactly how you end up with clunky, unscalable software absolutely crawling with bugs.
Designing your algorithms first, whether that's with flowcharts or just pseudocode, guarantees scalability. And because algorithms are completely language agnostic, understanding them makes picking up any new syntax a total breeze. Plus, mapping out your time and space complexity at this stage, that is the real secret to crushing those rigorous FANG technical interviews. Section 4, laying the foundation. All right, blueprints securely in hand, it's time to pour the physical foundation of our structure by picking our starting language.
And that brings us to the classic debate, C versus Python. C demands incredible discipline. It doesn't hide the machine from you at all. It teaches you exactly how memory, variables, and the CPU actually operate under the hood. Python, though, it abstracts all of that away so you can prototype incredibly fast and get straight to solving high-level problems.
Think of it like building a house. C is the hidden plumbing. It's the electrical wiring and the physical concrete foundation holding the whole thing up. Python is the beautiful, accessible furniture and the lighting. They complement each other perfectly. Learning C first gives you an unbreakable engineering foundation, while Python gives you unmatched productivity.
Section 5, the 2026 tool belt. Now we're at the top of our pyramid. Let's cut through the noise and look at the power tools that actually matter for real-world projects heading into 2026.
Let's start with Python. Look, Python isn't about raw speed anymore, and if you're chasing microseconds with it, you're doing it wrong. Instead, it's absolutely the best language for taking an idea and rapidly turning it into a working prototype. With its massive ecosystem, it is still the undisputed king of orchestrating high-level logic.
Then we have Rust. Yes, the learning curve is brutal. The borrowing and ownership rules will test your patience, but it's not just hype. Rust forces you into better programming habits, and it pays massive dividends when you're building durable, memory-safe systems meant to survive for years, not just quick throwaway scripts.
On the web front, vanilla JavaScript is frankly feeling a bit tired. TypeScript, however, is fully awake. Moving from JS to TypeScript is literally like upgrading from a tricycle to a Tesla. You have the exact same engine, but you get incredible type safety and developer velocity. It practically ensures you don't accidentally break your entire app every time you push an update.
Next up is Go. If you're building high-traffic APIs, Go hits this perfect sweet spot. It's fast, it's simple, and it's highly reliable. Just a quick warning, though. Keep your concurrency shallow and predictable. If you start nesting too many Go routines without solid error handling, you're going to cause massive panics in your system.
Finally, Kotlin. And hey, it's not just for Android development anymore. Kotlin's real strength right now is acting as a logic-only shared module. It flawlessly powers multiple platforms, mobile, desktop, and backend, all with cross-platform consistency across the Java virtual machine ecosystem.
Section 6. Mixing languages smartly. Because here's the ultimate takeaway. In modern development, there's no magical one language to rule them all.
The real secret is knowing how to strategically combine them. Keep Python for the orchestration, but offload the heavy, intense computation to Rust. Use Go to build a rock-solid backend API and pair it with TypeScript for a fully trusted front end. Don't force a pure Julia AI prototype if the syntax quirks are slowing you down. Instead, just step back and re-architect your bottlenecks intelligently.
This quote really hits the nail on the head for the 2026 mindset. Success isn't a popularity contest. It's not about GitHub stars. It is strictly measured by how few nights you spend awake debugging pointless mistakes. It's about reliability, excellent developer tooling, and actually solving problems without giving yourself a migraine.
So, I'll leave you with this question to chew on. Are you measuring your coding success by the latest hype cycle, or by how strong your foundational problem solving actually is? If you really want to thrive, stop chasing shiny new syntax. Master how to think, draft meticulous blueprints, lay a rock-solid foundation, and mix your tools wisely. Thanks for joining me on this explainer. Keep building smarter, and I'll see you next time.